Hey everyone, this is lesson 843 on circles in context. Now, up to this point, we've been discussing circles, how to find the area and circumference of circles, how to use area and circumference to find a sector area, which is a portion of a circle or a portion of the area. And we talked about uh, arc length, right? So instead of finding the whole circumference, just a portion of the circumference. So those are some topics we're going to kind of put into practice with a couple problems today in these notes. Two problems specifically. Um, One is focused on a windshield wiper. And then the second question we'll be talking about um, cookies, baking cookies, and wasted dough. All right. So remind yourself, if you don't already have it written down or memorized, make sure you probably want to include this in your notes so you have it as a point of reference. Formula for finding the area of a circle is equal to pi r squared, and finding the distance around the circle, the circumference, is 2 pi r. All right, so we're going to be using those in today's lesson. All right, so here's our windshield wiper problem. Now, you might have noticed most cars have windshield wipers. Some have one big windshield wiper, some have two. Most cars that I think we see have two. But they don't if you haven't noticed, they don't necessarily wipe the whole windshield, right? They do their best to wipe as much as possible. And so maybe a question you could ask yourself next time you see windshield wipers is how much of the windshield does it actually wipe? All right, so in this problem, this certain car's windshield wiper clears the windshield wiper in the shape of a sector, right? So you'll notice the windshield wiper goes, most likely it's going to go like this and like this. And it looks like a portion of a circle, right? It looks like it's just a piece of a circle, or maybe even a really big slice of pizza. We talked about pizza before. So that's what we're focused on here. So we definitely know some information. The wiper pivots at 120 degrees, so we know what the angle is there. That's something that's easy enough to measure. What is the area of the windshield that is wiped in each swing? So we're talking about this shaded area, just this shaded area, because if you've ever seen a windshield wiper, there's a portion of it that's actually wiping the windshield, and then there's another part that's kind of maybe holding that windshield wiper as it goes across your windshield. All right, so it doesn't necessarily have a really long wiper portion of it. So we have some extra measurements, not in the description of the problem, but in our diagram. The distance from the pivot point to where it actually starts wiping is 5 inches. And then from that point on, the actual length of the wiper is 15 inches. Okay, so what is the area of this shaded region? That's what we're trying to figure out. Okay, so I'm going to turn this into a pizza problem because we did a pizza problem on the previous lesson. If you could imagine if this was a slice of pizza, it's a big slice of pizza, right? Big slice of pizza. Imagine you have this slice and you start to eat it. Most of us are going to eat it from the pointy end, and you eat a portion of it, right? then that means there's a piece missing, and you would ask yourself, well, how much pizza is left? All right, so that's really the situation we have here. We have a large slice of a circle, but there's a piece missing. This white portion is missing. So we need to figure out what that is equal to and subtract it from the larger piece. All right, so let me see if I could summarize that. So let's see, the area of the wipe, I'll put wipe, is going to be the area of the whole sector minus, right, minus the area that's missing. So let's say I'm going to just call this like the pivot, only because they use that word here, the pivot. Maybe it'll remind us where it's coming from. So this portion, oops, we'll say is the pivot area. All right, so if I want to know the area of the actual wipe, the shaded region, I would find the area of the whole piece and subtract this pivot area, right? Or it might be like the bite or the portion that you ate out of the slice of pizza. All right, so now we have a kind of like a formula to work with. So let's just fill in what we know to solve for a sector area. All right, so let me write, so let me use the same color. Area of the wipe is, so how do I find the area of the whole sector? Well, we talked about this last time. We need to know what portion of a full circle is it actually taking up. Well, that's where they give us the 120 degrees. So we're going to do 120 out of 360. That's the portion that we're looking at. Times, we want to find the actual area of the whole circle. So if you imagine this was part of a larger circle. Right? If it was part of a larger circle, that's an ugly looking circle, but we want to find the area of the whole circle. All right, so we're going to use pi r squared. Let me use brackets. So let's do pi times r squared. All right, so that's going to give us the area of the whole. Now that means r squared. I need to know the radius. If we do have a circle, what's going to be the radius of this circle? Well, we do have these measurements here. So from here to here, you'll notice it's 15 plus 5. 15 plus 5 gives us a total of 20. So let me write that here. So 15 plus 5 equals to 20 inches. So I'm going to put in a 20 inches there. All right, so that'll give us the area of the whole movement of the windshield wiper. But we said there was a piece missing, that white portion. So what I'm going to do is then subtract. I use a different color here. So we want to subtract the piece. So we're going to subtract us. Really, it's just a smaller sector, right? So now if we only focus on the small piece, we're going to do the exact same work, except it's going to have a smaller radius, right? It's going to have a smaller radius. So let's do 120 over 360. It's still the same size of an angle, times pi r squared. All right, so in this case, what's the radius? That we're going to be using? Well, it's going to be 5. All right, so this is pretty much our answer. We have everything we need. We just need to simplify it at this point. So I'm going to, let me ask you a couple questions. Is what does 1 over 20, oh, I'm sorry, 1 over 20, 120 over 360, what does that fraction reduce to? So what's the smallest fraction that we could get from this? So go ahead and see if you could think for a second and let me know. All right, so if you said it was 1/3, you'd be correct. So this is 1/3. The reason why I wanted you to think of that, because that means both of these are going to be 1/3. Okay. Now we would focus on the squares. So we're going to do 20 squared is going to be 400. Don't forget the pi still's there. And then 5 squared is going to be 25 pi. All right. So at this point, area of the wipe is equal to this. So let's write these as fractions for now. So I'm going to rewrite these as, this is going to be 400 pi over 3 minus 25 pi over 3. Okay, so now you'll notice we have two fractions. They both have the same denominator, so it definitely makes it a lot easier to do the calculations here. So this is going to be, what is 400 minus 25? This will be 375 pi over 3. Right. And what is 375 divided by 3? So what does this reduce to? Let me see if you could tell me what this reduces to. Don't forget pi in your answer. All right, so if you did your calculations, hopefully you ended up with, I'll do it below. So this will be, the area of the wipe is going to be 125 pi. Now this is in inches, so we're looking at inches squared. All right, so if you forgot to put inches squared, that's all right, put that now. And now that's, technically that's an exact answer. It probably would make more sense for us to see this in a decimal answer form. So this is an exact. Let's approximate, run this through the calculator. So approximate, let's see, area of the wipe is equal to, I believe if you put that in the calculator, 125 times pi, it should give you 392.7 inches squared. All right, so here's two ways of writing your answer. We have an exact at 125 pi, and we also have an approximated, oh, let me change this to not squiggly equal sign. All right. All right, so those are, that tells us exactly how much area is being covered by this windshield wiper. So that's something you could definitely calculate. You could go out to, maybe you have a car, you could measure the windshield wiper. Maybe you could check to see how wide that windshield wiper opens. You can measure that angle. Maybe you could just approximate it if you don't have a tool to measure angles. And then actually see, you could actually calculate how much of the windshield it is wiping. All right. All right, hopefully that wasn't too difficult. This is the basic idea, was using a sector area, how to find the area of a sector. The only thing more complicated here was us having to subtract, do it really those two problems and subtracting them in the end. So hopefully it probably looked more complicated than what it was. All right, a second problem is our cookie cutter problem. So here we have a cookie baker. So he has an automatic mixer that turns out a sheet of dough in the shape of a square. So he gets this whole complete sheet of dough that is in the shape of a square, and that square is 12 inches wide. His cookie cutter, his actual tool that he uses to cut cookies, is a 3-inch diameter circular cookie cutter. So the supervisor complains that too much dough is being wasted and orders the baker to find out what size cookie would have the least amount of waste. So we have to start by figuring out, well, how much dough is actually being wasted to begin with. So we're going to start this process. And if we were in the classroom, I'd have us test out different size cookies. But we'll just start that process here. We want to figure out, well, how much cookie dough is lost based on the information we have. All right. We have some measurements. The cookie dough is 12 inches wide. Well, it's the shape of a square. So I have this square shape for us. This is 12 inches wide. So 12 inches. It also happens to be a square, so that means it has 12 inches tall as well. All right, and the cookie cutter cuts 3-inch diameter cookies. All right, so that means if we use this 3-inch diameter circular cookie cutter, then how many cookies can we fit? Well, I've put in, if you already noticed, I already put in the circles that would fit. So if the diameter of this cookie is 3 inches, then there would be another 3 inches, and another 3 inches, and another 3 inches. That is a total of 12 inches, right? Which would be the most that would fit. So our other option is to use a different size cookie cutter that maybe fits more cookies, but maybe has smaller size cookies, right? Is that a better option for us? So that's what the baker wants to know. Well, we're talking about wasted dough. Wasted dough. So if you haven't noticed, there's these gaps. There's these gaps in between the cookies. This is dough that is not being eaten. So this will be repurposed. And so the baker says, well, I want to make sure we don't have anything wasted. We want to make the right size cookies so we can maximize our cookie production and not waste any money. Literally, not waste any dough. Get it? Dough? Money? All right. So let's do some calculations. What is the area? What is the area of all, not the cookies, but everything that is not a cookie? That's what we're trying to figure out. So how in the world are we going to find the area of all this space? This is not even a nice shape. So two things. We know how to find the area of a square. So we could calculate the area of the whole thing. And we know how to calculate the area of a circle, right? We're assuming these cookies are going to be pretty much perfect circles for the most part. And so if we could figure out the area of the whole square, then maybe we could subtract, we could get rid of all the cookies, right? Now, do we have to find the area of every single cookie? Does that mean we have to do this, what is this, 4 times 4, 16 times? Well, if all these cookies are the same size, then really we just have to do it once. And then multiply that by 16, and that'll give us the total for all the cookies. And if we take those out, then we're going to be left with just the leftover dough, which is exactly what we want to know. All right, so let's do this. So area of waste. We'll call this waste because that's the leftover dough. So let's start with the area of the whole square sheet of dough. So the whole thing is going to be the area of the square, right? That's the whole thing, minus the area of cookies, all right? All the cookies. So now that's what we need to calculate. All right, so let me throw in our measurements that we already know. So from, we already know the size of this width is 12 inches, right? We also know it's going to have a height of 12 inches. All right, that's what we know. And the cookies, in this case, are, what's the radius of each cookie? So keep in mind, we were told this is 3-inch diameter, 3-inch diameter. So what is the radius? All right, so if you remember from before, anytime you have the diameter and you want to know the radius, you just have to divide it by 2. So the radius is going to be 3 divided by 2. You could use a fraction if you want. Most of us would probably use decimal 1.5. All right, so 1.5 would be our radius, and this is going to be inches, 1.5 inches. All right, so now we know the radius of the circle, so that should be all we need. And we know the measurements of the square. So let's see if we could take that information and make some progress here. So area of a square, you need to know the formula for finding the area of a square. So any square, rectangle, parallelogram, shapes like those have the same basic formula, and that's going to be base times height. So let me use a different color for this one. So I'll put the formula first. So base times height of the square, and then we're going to subtract the area of the cookies. Now, how many cookies are there going to be? So 16 cookies times the area of one cookie. So in this case, formula for that is going to be pi r squared. So I'm going to write it out like this first. Okay, so now that you know, now we just need to plug in the numbers. And let's start with base and height. All right, so we're going to plug in 12 times 12 minus 16 This is going to be pi r squared. All right, and then we said the radius was 1.5. Okay, so definitely, I think this is set up correctly. Yeah, let's do this first. So area of the waist is equal to, so 12 times 12 gives us 144. That's easy enough. Minus, now we need to figure out what this portion is. So if we simplify all that, probably want to start with 1.5 squared. So 1.5 squared is going to give us 2.25. Right. Unless you left it as a fraction, then you would have 9/4. It actually would work out nicely as a fraction. All right. Okay. So next step is to maybe multiply that out. Area of the waist, 144 minus, now we just have to multiply 16 times 2.25. And when we do, we would end up with a nice number of 36 pi. All right, so this is going to be inches squared. This would be an example of an exact answer, which hopefully you're seeing this, and that would not make any sense probably to anyone. It's a really good answer. That's how you would write an answer like this. But we want to know actual numbers. So this is a good example of when an approximated answer is going to make way more sense for us. So we could decide how much dough, actual dough, we're wasting. So the area of the waist, let's see, go ahead and put that in a calculator and see what that gives you. See if you know how to type that in a calculator. Most calculators have a pi button. Look for it. Your answer will be a little bit more accurate. If you can't find a pi button, then if you type in 3.14 instead, that'll give you something pretty close. All right. So let's see. I'll type this in. I haven't even done this. So 36. All right. So if you type that in, hopefully this is what you got. 30. Oops. This is going to be 30.9. 30.9 inches squared. All right. So that's how much cookie dough is left over that's not being used. So question is, if we change the size of the cookies, can we fit more cookies in, smaller cookies, and not waste as much dough? Or should we make the cookies bigger? And fit less cookies, and will that give us less waste? So I'm interested in knowing what you think what will happen if should we do like one big cookie? Should we do one big cookie? And will this space be smaller on the outside? Or should we do tiny cookies? Tiny cookies and the space in between, is that going to be smaller? All right, I'm curious to know what you think. Let me know. And also after that, that'll be it. And let me know if you have any questions as well.